What is the most used man-made material on Earth? You guessed right, it's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic Podcast. And today I have EKoehler with Titan. Eric, could you give us an introduction to yourself?
Sure. Well, Seth, thanks for having me. I appreciate being on the podcast today. So I work in product development, quality, sustainability for Titan America. We're a cement, concrete, aggregate, and fly ash company focused mainly on the East Coast of the United States. Been with them for about 8 years. Before that, I worked in the admixture industry on a lot of the same topics. That's me.
Yeah. No, I appreciate you coming on. I mean, Titan's one of the bigger cement suppliers, and not just the East Coast, but you guys are international as well. And so what y'all do has a big impact on the industry. And but I know today you wanted to talk about some things that you've been working on. And your focus that's been in your career as far as the what's going on in the Inflation Act and buying carbon reduced concrete and what all that means. So is there a particular spot in there that you wanted to start? And we'll just kind of go with the punches here, and I'll ask some maybe some questions that are not that intelligent, or maybe intelligent. We'll see.
Yes. So we're seeing a lot of demand increasing for low carbon concrete. We're seeing it. You mentioned the Inflation Reduction Act, which recently passed in Congress, that has a lot of money for the federal government to specify low carbon concrete. So that's coming. Those policies are coming. They're not fully here yet, but we're seeing owners, we're seeing others request low carbon concrete. And so this podcast is a great platform to really talk to all the different stakeholders across the value chain that are involved in specifying and purchasing low carbon concrete, and then people like yourself, Seth, who have to actually pump, place, and finish that concrete. So I thought that would be a good place to start because a lot of times we get these specs and we have to have some education and some back and forth and some dialogue with owners on what's possible and what their goals are. And so having this out here on a podcast, I think is useful. So we call it buy clean is the term you hear a lot, green procurement, typically on the government side. But it's not just the government, it's owners of private buildings, it's investors that are very interested in achieving this. So how do we quantify that? How do we communicate between buyer and seller on the characteristics of the concrete and achieve the goals that the owners ultimately want? Yeah.
So before we dive into that and the way you're trying to convey what they're asking for, because I think what's happening is these folks are asking for something that they might not necessarily understand what they're asking for, because there's maybe some kind of incentive, right? There's some kind of incentive for these owners. Obviously, the government is following policy that is being dictated in D.C. So I kind of understand that, and we can talk about the Inflation Act and everything. But is that what I guess your understanding is the folks that are asking for the buy clean concrete, as you put it, is that because there's an incentive to it?
Yeah, I think there's really three areas where it's coming from. There's the government that you mentioned, where there's policy in place to encourage use of low carbon concrete. There's the investment community. So ESG investing is one of the fastest growing spaces in investment. And so when companies are looking at investments, they want to know what is the carbon liability long term, what are the climate risk associated with a company. And so if a company uses a lot of CO2 in their buildings or as a manufacturer in manufacturing cement and concrete, they're going to look at that. And so there's emphasis there. So the SEC recently came out with some proposed rules that would require companies to report their what they call Scope 3 emissions, which is from their buildings. And so it's still a proposed rule. It's not final yet, but when a company reports their earnings, they would also have to report how much carbon they're using across their operations. And so there's an interest there. And then the third area is that there's companies that have public commitments, and they feel very strongly and that they want to be a leader in decarbonizing their operations. Maybe they're getting pressure from their own customers. Maybe it's something that they feel strongly about, that they want to reduce the CO2 footprint of their operations. So there's probably three main areas that are kind of coming together at the same time and translating into requests for low carbon concrete and low carbon buildings.
Yeah. Yeah, the CO2 is the big thing that everyone's focusing on. Do you think there's a couple questions there I wanted to ask you, but I guess the first one is: do you think the focus on the CO2 is the main driver for this? I guess buy green. I like your term better. Buy green better than the carbon reduction thing, because to me, if we want to be green, there's more to being green than just reducing CO2. Is that the main focus, Eric? Is what you're seeing from the top down?
Yes, I think that's the main thing is carbon. So I think there's been a lot of emphasis on other environmental aspects over the years, and so looking at recycling, reusing returned concrete, things like circular economy, making sure that we utilize all the materials that we make in the cement manufacturing process and the concrete. So there's increasing demand for those as well. There's interest there, and ensuring we have circular economy and looking at water and other types of emissions. But CO2 is the new thing, and that's really I think the biggest challenge, and also the one that's most of interest.
Do you think that the focus on CO2 is because that's the thing that we can fully understand, that it's maybe easier to quantify than something else?
Yeah, I mean, if you get an EPD, the EPD, there'll be a full page of all the different environmental impacts on there. And everyone just looks at the first line, which is the global warming potential, which is the CO2 equivalent. And so I think that's the biggest challenge. And with the Paris Climate Accord setting this 1.5 degrees C, it's really the CO2. So the other things the other emissions we have as an industry are highly regulated. We're a highly regulated industry, and we've made a lot of investment over the years to reduce things like SOx and NOx and manage water emissions, manage waste emissions, all of those things. We've been working in that for a long time. I think the CO2 is the new thing and the biggest challenge.
Right. So it's just the next step in that. Mm-hmm. Okay. Yeah. So as far as this buy green, we were talking before we hit record. You were saying the challenge is to get these owners to understand what they're actually asking for. What do you mean by that? Where's the I guess disconnect?
Yeah, so I think the first thing that's important is that we're all really working towards the same goal. So the concrete industry, the cement industry has come out with roadmaps on how to get to net zero CO2 by 2050. And so if you zoom out even further, you have this limit of 1.5 degree C temperature rise from pre-industrial levels. So the consensus globally is we need to stay below this 1.5 degrees C level. In order to do that, we need to be carbon neutral by 2050, and we have to be making progress towards that goal every year. And so the concrete industry has developed these roadmaps. The company I work for, a lot of other companies in our industry have come out and publicly committed to achieving those. They've had targets and our roadmaps scientifically validated. So the first thing I think is important is we're all working toward the same goal. It's really coming down to individual project, individual concrete mix of how as an owner can you communicate to the team to come up with the optimal solution. And so you have a project, there's so many different parameters that have to be managed, not just on carbon, but on schedule, on cost, on constructability. And so putting all that together and now putting one more factor in there, which is the carbon, it's a very complicated problem. So it's not a simple solution, but there are some frameworks that are emerging, and so I think it's going to get easier over time. But for now, really the best the best approach is to start with the whole building life cycle analysis. So most of the emissions are related to the use phase. So really, if you're going to have the biggest impact on the CO2, it's really starting at that level. So pavements, MIT has shown around 70 to 80% of the use phase, the emissions are related to the use phase. In buildings, it's 80 to 90%. And so if you can start there, you're going to have a much bigger impact on the overall emissions of that building than just looking at the concrete. And then if you think of the concrete, if you think of the resiliency of concrete, the durability of concrete, the fact that concrete recarbonates and reabsorbs CO2 over time, and that it can be recycled, all of those things have a big impact, regardless of your mix design, regardless of the global warming potential of the concrete. And so those, taking those into account, and then you get to the last step and you say, okay, I'm going to specify individual concrete mixes, and I want to make sure those are as low as CO2 as possible while still maintaining performance, constructability, all those things that I want. And so so that's really the key part of the process, but that's a lot of steps, and probably each of those could be a separate podcast. But perhaps we could talk more about the final step where you're actually specifying concrete. That's what I deal with a lot in my current role. Okay, now you've done all that work. Hopefully you've done all that work, and you want to get the lowest carbon concrete. How do you effectively make sure that you're getting that?
Yeah. So how do you? I mean, we've tried stuff over here on how to, I guess, benchmark that. How are you benchmarking that, I guess?
Yeah, so I think EPDs are the best thing we have. They're not perfect, but they're the best thing that we have because it gives you a bottom line number of how much CO2 per cubic yard of concrete that you have. And so, we can go into EPDs and why they're not perfect, but they're a good guidance to choose a low carbon mix. And then you need to have a baseline. And you want to have a reasonable baseline. And so I think that's where the big challenge is, because concrete is such a local material. And so what you're capable of doing locally is going to vary different areas. And so you really want to let the concrete producer innovate, give them flexibility to achieve the lowest that they can. So I think it's sort of a back and forth. There are some national benchmarks that people often use, and those are a great starting point. But you really need to understand for your market and your project what is what's possible, and then kind of a back and forth and say, okay, well, I want to get if I'm in New York, if I'm in Texas, if I'm in Florida, and even a specific city within those states, what's the current state of practice in that market, and what are the options for reducing it more? And it's going to have impact on cost. It's going to have impact on schedule. It's going to have impact on constructability. But making sure that you look at those trade-offs and you decide what's best for your project.
Yeah, no, I think you're right on. It is a very local challenge versus national, or even there's international. I guess that's the frustrating side of this whole effort for me, is that we're trying to I guess use a global solution to something that we got to, like you said, drill down to the local level to actually have an impact on what we're doing on each project. Because I mean, what you do in Florida, you can't necessarily do in Virginia, and vice versa. So it goes all the way down to not just the cement, but the aggregate and sand and everything else that you're putting in concrete. That all has an impact on how it works, and that's why concrete's so fun, because it's never the same thing each time. So, but I guess what I've seen is that you kind of benchmark what I think on the national level, in our MCA, did I say that right? National Ready Mix.
Yes.
Yeah, that's a mouthful, isn't it? They have a benchmark that they've been sharing, right? I believe nationally, and for each mix design, so like a 3,000 mix, a 4,000 mix, and a 5,000 mix, and this is typically how much cement that you use in each mix design. And then if you're able to reduce the amount of cement, that's good compared to that benchmark. Or that obviously would reduce your emissions, your CO2, and also using not just reducing the amount of cement, but also using other fly ash, slag, or other types of cement like 1L, which we've talked about on the podcast in the past. Is that the way you're approaching it, or what's your approach?
Yeah. So you mentioned the NRMCA benchmark. They have that nationally, and then they have different regional values for that. That's a great document. It was a great start. But concrete is more nuanced than that. I mean, we talk about looking at EPDs. There's the term that you'll hear with EPDs a lot is it needs to be functionally equivalent. And so concrete has a lot of functions. It's not just strength. So there's the NRMCA benchmark. There's something called the EC3 tool, which is they compile essentially all the EPDs, and then they can take an average. They can take medians, and they can take ranges of CO2 associated with different strength classes and other things. GSA, the General Services Administration of the government, has come out with their own spec for low carbon concrete and what that means to them. So I think with the national averages, first of all, there's a lot of regional differences. A lot of that comes down to what kind of materials you have available in your market, and then what the environmental and other specification requirements are, and then the transportation. So if the transportation component is a big component, and you can easily exceed any savings you get by bringing in a material from longer distances. So you have to put all that together and optimize the design for that. So so I think the key thing is looking at really what's even a local market. So the NRMCA benchmarks, those regions are quite large, and you can have variations even within those regions. And then the NRMCA is based on strength, but we all know concrete has a lot more. So is it air entrained versus non-air entrained? That's going to have a difference. Does the concrete need to be pumpable? And then a lot of times, an engineer will write a spec, and they'll look at 28 or hopefully 56 days strength for that concrete, but then the engineer's not necessarily thinking about the construction schedule and what are the other higher strength requirements, other things that need to complete that project on time and successfully. And so those are things that if the engineer just looks at the project and sets a baseline based on the strength and based on what's in the NRMCA or the EC3 tool, they may not get a realistic benchmark for that. So I think it's really understanding the full functional equivalent is the term of the concrete, and making sure that your benchmark is realistic. Because I've seen people put these graphs up and they say, okay, here's 4,000 psi. Here you can go to the EC3 tool, for example, and you can pull up 4,000 psi concrete, and there's a huge range of CO2 associated with 4,000 psi. And some people say, well, what's wrong with all these very high values? Why can't they all be at the bottom? Well, they can't, because 4,000 psi is such a broad class, and so there are a lot of those that need early strength. They need to be pumpable. They need to be. They have different requirements for finishing, and maybe air entrained, maybe non-air entrained. So all of those things are going to have an impact, and they need to be considered in setting a benchmark. And so I think the EC3 tool is great because it's adding a lot of that data, but we're still not fully there yet where we need to be. So one approach to doing that is to set a carbon budget for the project. Just say, okay, you're going to have some mixes that will be well below the target. Some mixes may be a little bit higher. But when you look at the total CO2, not CO2 per cubic yard, but the total CO2 per building, is that below the benchmark of where it should be? So you can kind of smooth out some of those things that may not be explicitly in the design spec, or may not be explicitly in the benchmarks. And you can also work with your local suppliers to establish what factors should be included, and what it means to make a mix pumpable, what that means for CO2, what that means to add water cement ratio limit. If the engineer wants a water cement ratio limit, what does that mean for the CO2, and understanding all those different levers. So it's sort of a back and forth. It's more complicated than just looking at a table, but if you do that back and forth and you have that conversation, you can really start to figure out where you can have the biggest impact and what's a realistic reduction scenario.
So what you're saying is you're looking at the total building and that type of building, and then coming up with a allotment of carbon that can be used, I guess, to build that building and the life of the building as well. Is that what you're saying?
Yes. Well, you would come down to the end and you say, okay, this building can have so many thousand tons of CO2, and then let the contractor, let the ready-mix supplier work together to come up with the optimal solution for that. So you may have some high early mixes, some post-tension slabs that need to have high early strength, and you're not going to meet the global warming potential, the CO2 target for those mixes. But then you're going to have some other footer mixes, maybe some paving, where you can actually exceed the targeted reduction and do better than the benchmark. And so you come out overall with a solution. So that's kind of the simple way to do it. If you want to be a little bit more detailed and include make sure you have the right functionally equivalent benchmark. So you're taking into account the fact that an air entrained concrete may need to have a little bit more cementitious, may end up having a little bit more CO2 than a non-air mix. Mix that needs to be pumpable, mix that needs high early strength, is going to have a little bit. All those mixes are going to have more CO2. Then you can target it a little bit more precisely and get a more realistic benchmark. But you already get too complicated, it'll get really complicated quickly, because concrete, when you look at a spec, there's so many different attributes of that concrete that have to be optimized, and all those have an impact on CO2.
Yeah, no, I think I'm understanding what you're saying is that if we're looking at the entire, so from construction to finish of the building, and how much CO2 it takes to get to that point. And then also, as the building is operating, how much CO2 does it put up in the air? And saying, hey, this is the bank of CO2 that you have for this building. And is it over a duration of time? Like, are we looking at decades? Are we looking at it that?
Well, really, the whole life cycle of the building, however long that building is designed for, and then even including the recycling of the materials. So right now, an EPD just considers the first 3 stages. It doesn't. It's basically cradle to gate, and then a whole building life cycle analysis would include all the way through recycling, and also the fact that concrete is going to reabsorb CO2 over time. So about 20% of the calcination emissions from cement production are reabsorbed over time. So that works out to about 10% of the CO2. 8 to 10% of the CO2 is actually reabsorbed by the cement over time. And so that gets included in there as well. And then when you can recycle that concrete at the end of the life, that also gets taken into account.
Yeah. Yeah. How's that effort going, though? I like that. I think that's awesome that we're looking at that at the entire life cycle of the building, and so we're talking getting people to understand the impact of a building over 4 or 5 decades, and then there's other considerations when you're designing these buildings. Is obviously we're rooting for concrete because we think concrete's the best material in the world, but as far as the building envelope and how efficient it is, and how the more efficient the building envelope is, the less mechanical HVAC type of equipment use there is, right? So that's I imagine what you were saying at the beginning of our conversation is if I heard you right, was the construction of a building is about 10% of the CO2 that it puts off, and then the 90% is the life of the building as it's operating, and that's when it's putting up the majority of it. Did I understand that right?
Correct. Yes.
Yeah. So tackling that 90% is very important, but it seems like we're focusing on the 10% of the building, the constructing part of it, and making efforts there. Which I'm not saying we should not do that, but I like the idea of looking at the entire life cycle of the building versus making a decision on like you're saying, making the decision on a concrete mixes based on a very small percentage of the of all the CO2 that a building could emit. Because I'm really interested. I'm hoping to get somebody on the podcast and I've been following some people on the passive housing design, which sounds pretty cool. And the point one gentleman was making was when folks, like, say you build a multifamily building, a bunch of apartments, being able to convey to the folks that are renting those apartments is the energy use for each one of those apartments, compared using that passive design versus I guess traditional design, and comparing those to utility costs, and bringing that to folks' attention, because basically what they're saying is your electric bill, say you rent a stick-built apartment, and your utility bill could be a couple $100, but the passive house could be half that, is what I'm understanding, and I want to learn more about that, which sounds pretty cool. And obviously I'm following it close, because a lot of those, I think most of all of the ones I've seen have some component of concrete involved in it, as far as the building envelope. There's guys out there. I think they're using precast panels, which are obviously concrete, and I think some ICF is another concrete system that folks are using for that as well.
Yeah, so absolutely. I think concrete is really a perfect material for passive house standards. So there's been a lot of work on ICFs, on precast panels, even 3D printing is an area that applies. So with 3D printing, if you think of a passive house, making that a stick-built house, it's almost like building three walls to really get the insulation value you need and to get the high-performance wall system. If you're going to 3D print it out of concrete, then the printer does all the work. The robot does all the work, and so it makes it a lot simpler. You can get rid of the thermal bridging. You can get continuous insulation, and you can build a really effective wall system there. So a lot of the 3D printing houses that we're seeing come up are actually able to meet passive house standards, are able to come in as net zero houses. And so, you think of decarbonization, reducing the CO2. You think of just, okay, let's minimize the CO2 from the cement. Let's minimize the amount of cement, and that's important. But also, what can we do? So, think of 3D printing. It's a you think of more of it's a digital technology. It's really exciting on the technology side, but there's a huge potential on reducing CO2 of buildings with that technology, because you can print high performance wall systems, and the robot does all the work.
Yeah. Well, we're following that along. I'm not sold on the 3D printing yet. We got a ways to go on that one. But the passive design, it just makes a whole lot of sense. It's like, let's build our homes and our office buildings and to a point where they operate more efficiently. Especially, again, not to hammer that point down, but the 90% of the emissions occur when the building is operating during its life. So that seems like that'd be something we should be focusing on. But I've had discussions before with other people. It's hard to get people to think in decades, and I'm sure that's the big challenge for all of us, is to get people to think in decades. It's a lot easier to pick on the concrete guy and say, "Hey, man, you're using a lot of cement. You need to reduce your cement," and so we can meet our goals. I think that's a lot easier than people to wrap their head around. I also don't think investors necessarily think in that. Most investors, I won't say all investors, but a lot of investors don't think in terms of decades either. So,
I think when you're buying a house for your family, when you're building an office or a store for your company, you have so many different parameters that you're trying to optimize, and so sustainability, you're always going to make a compromise. You're always going to give something up to get something else that you want. So. If you're buying a house and you're trying to figure out what is the right school district and the right commute time and all these other things, you may want low carbon, but you have a very tight time window. You're relocating. You have a very tight time window. You don't have time to incorporate all of that. And so, just because we don't have people saying they want it, is not the market is not necessarily telling us exactly what people want. And so, I agree with you. If you had the option, you would take it, but a lot of people, we're not giving people those options.
Yeah. That is the challenge. I think that's a good spot to end the podcast today, Eric. If folks want to reach out to you and learn more about your efforts, what's the best way?
Yeah, probably the best way is on LinkedIn. You can look me up at Eric Koehler on LinkedIn. And then we put my email address in the show notes. It's kind of a long one, so we can maybe put it in the show notes, and feel free to contact me there as well.
Yeah, we can do that. That's not a problem. Eric, I appreciate you coming on the podcast, and we'll have to do it again.
All right. Thanks so much, Seth. I enjoyed it.
Yep. Not so bad, huh? Thank you for joining us for another Concrete Logic podcast episode. If you got some value out of this or you enjoyed it, please share it with others. And if you could take a moment and give us a 5-star review on your favorite podcast listening app, I would appreciate it. We will catch you on the next episode. And now Mike Dunton's going to take us out.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done. With wood, iron, and mud, we work hard for $1, give thanks to the Lord above.